Did you know that smart grid technologies are creating new methods to support energy distribution systems and enhance reliability? Advances in communication, computing, and sensor technologies are creating new alternative solutions to traditional approaches of meeting ever-increasing demand. Here's a quick look at how emerging smart grid technologies in the form of a virtual power plant can be leveraged to improve grid reliability as an alternative to installing additional infrastructure. To see how this works, let's use a segment of the grid in Queens, New York as an example. A typical area station in Queens brings power from the transmission system to an urban neighborhood on the order of hundreds of megawatts. It is based around 4 transformers supplying the peak load, with the 5th transformer in standby in case of a contingency event or failure of one of the others. Presently, this segment of the grid can easily handle the loss of 1 substation transformer, or an N-1 event, because a backup transformer is already in place. Here, you can see the system is designed to maintain reliability and 100% power capacity if a single substation transformer fails, because a backup transformer can supply the load. During an N-2 scenario, a second failure follows an initial failure and results in 2 substation transformers becoming unavailable. In this scenario, the grid equipment would be operating at above rated capacities during peak conditions, and without additional support, the grid operator would be forced to disconnect customers or equipment would begin to fail. Using conventional technology to achieve N-2 support, the system would require the addition of another substation transformer, and real estate in Queens is at a premium. Adding capacity to achieve N-2 capability would require substantial capital investment. Another option would be to address these contingencies using smart grid technology. This example demonstrates how a smart grid can be used to improve reliability in the case of N-2 events. By leveraging communications, intelligence, and sensors, a wide range of distributed energy resources can be treated as a virtual power plant. This involves the collection of data from thousands of different distributed energy resources via a secure communication infrastructure. These resources can be aggregated and controlled like a traditional power plant by a system operator. Examples of these resources are smart meters and smart appliances that are distributed throughout the grid enable demand response, which encourages the shedding of load or turning off of appliances during constrained conditions. Energy and thermal storage technologies throughout the grid, which store electrical or thermal energy during off-peak times and discharge during peak times. Conservation voltage reduction is a process to systematically reduce voltages on the distribution network, resulting in a proportional reduction of load. Solar technology is also deployed to provide renewable energy generation. Conventional distributed generation is used as emergency backup for customers and can also be leveraged as a resource. So here's how this virtual power plant technology can be used to address an N-2 scenario. During an N-1 event, proactive communications to the virtual power plant puts those distributed resources at a high state of alert. Weather and demand forecasts are fed into an intelligent controller to determine the optimum dispatch scenario in the event of a second failure. When a second contingency event occurs, or N-2, the intelligent controller automatically reduces load in real time to reduce the risk of the remaining 3 transformers getting overloaded, using the virtual power plant resources if load exceeds the ability for the grid to meet the demand. Through the use of smart technology in the form of a virtual power plant, a smart grid is a viable alternative to traditional methods to improve reliability. And when you compare the investment required for conventional technology with a smart grid approach, a virtual power plant can become a viable alternative to improve or enhance grid reliability.